Good morning, everyone. As you all well know, the Arctic is melting down. We're also witnessing an uptick in extreme weather all around the Northern Hemisphere in all sorts of types: flooding, heat waves, cold spells, and droughts. The question is that we're addressing here today is, are these two things connected? As we also know very well, half of the sea ice in the Arctic has melted. In the upper right here, you see what it looked like less than a generation ago, whereas down on the bottom there is what it looks like today. And why is this important? Well, we all know many reasons why this is important, but one of them is that having lost so much sea ice in the Arctic means that we've lost a big fraction of the mirror of the Earth. And so by losing the mirror of the Earth, much more of the sun's energy is being absorbed into the climate system that before would have been reflected back to outer space and never would have entered the climate system at all. That is one of the functions of sea ice. One of the other functions is to isolate the heat in the ocean from the atmosphere. So having lost that ice means that we now have much more heat being released into the atmosphere. And these two functions of sea ice are contributing to the rapid increase in temperature that we've been observing in the Arctic. This is showing the changes in the temperature near the surface over the last 25 years during the wintertime. And you can see that the warming in the Arctic far, far exceeds that in the mid-latitudes. And in fact, in the winter, we even see cooling happening over the continents in Asia and in the eastern part of North America. So how could this be happening? And part of the cause of that change in temperature is that when we warm the Arctic faster than the areas farther south, it's that difference in temperature between those two regions that is one of the main forces that drives the jet stream, which is this fast-moving river of air high over our heads. When the Arctic is cold, back in the good old days, and occasionally now too, this is an example from 2013, we're looking down on the North Pole here. That blue color is telling you that the Arctic is very cold. When that's the case, we have a very strong and relatively straight west to east flow in the jet stream. This is an actual example. But when the Arctic warms up a lot, as we've been seeing consistently over the last few decades, we tend to see the jet stream, those red arrows, taking a much different sort of a path as it travels around the northern hemisphere. You can see that those red arrows have moved southward, and they're taking a much more convoluted path. We're seeing much bigger north-south waves in the jet stream. And why do you care about that? Well, those waves in the jet stream are what control our weather. And when those waves get big like that, they tend to move very slowly. And when they move very slowly, we tend to see our weather patterns change much more slowly as well. So the weather becomes much more persistent. Think drought, think heat waves, think long cold spells. So we believe that a warmer Arctic is going to lead to a more frequent occurrence of this type of jet stream pattern. Well, that brings us back to sea ice. And you've seen this graph several times these last few days. What we're seeing is the summer sea ice extent going back to the beginning of the 1900s. In gray is what's happened in the past. The black line is showing us what the real world has done, and the colored lines are what our future may hold. So we have a choice. We can stay on this red curve, which is the path that we're on right now. And as you see, we'll lose all of the sea ice sometime between the middle of this century and towards the end of the century. These are model projections for the future. Or, as Bill and Phil have already described, we can be very aggressive about removing carbon from the atmosphere. We can do that in a number of ways, and we have to do it in all ways, because we're never going to get on that green line and save some of that sea ice, prevent some of the extreme weather that we expect to see if we don't act aggressively in removing carbon from the atmosphere. Thanks.